Hi, good afternoon. Welcome back to my channel. This is Carrie. I'm Carrie Brace. This is Dark Horse Cues, and I do these tutorials on how to incorporate something like Fusion 360, a CAD CAM design tool, integrated into using your CNC machine, 3-axis or 4-axis CNC machine. And in this case, we're going to be designing a pocket that's for an inlay. The inlay there are long diamonds, little spearhead diamonds that are going in between 2 points floating, well, not floating points, but on a full splice cue. And the sketch is going to look like this. I've already created this, but I want to recreate it so that you can see all the steps that I went to create this particular sketch and profile. So in Fusion 360, all your tools are up here, and you can hover over any of the tools and just let go of the mouse, and it'll tell you what it is. In this case, we're going to create a sketch. So this box over here shows you your vantage point of looking at the plane, and we know that on a 3-axis CNC machine or a 4-axis CNC machine that we use the Cartesian coordinates. So we got the X and the Y and the Z, Y being in the positive, X being in the positive. So I'm going to go back to here and go back to here, and normally when you first start a sketch, it asks you what plane do you want the sketch to be on, and this is the look that you get. And I'm going to select this plane, and it's going to flatten it out for me. And I want to start with a line that's a construction line. I don't want to draw just a straight line, and the difference between the two is that I can draw a line like that, and that's a regular line. I can use the L key for line, or I can select construction and draw a line like this. So both of these lines are, one's what would consider a solid barrier and one's a construction line. The construction line helps for when you're creating a profile or a design where you don't want to get any confusion about getting that selected into creating whatever it is that you're going to be doing on the machine. I'm going to delete these two. So I do want a line, and I'm going to hit the construction tool, which I've already done, and I want to lock this into this plane right here. I want this to be on the X0, and I want it to be 2.5 inches long. So you can just start drawing it out, and as long as you're not at an angle, it'll snap to. And if you have questions about snaps or anything like that, let me know. But I don't want it at any degree, and I want it 2.5 inches long. I'm just going to type that in and hit OK. So I know that it's 2.5 inches long, but the line is blue or red as construction is, and it's not black, and so it's not fully defined. So there's a few things that are going on with this line. One is that it's not locked onto this 0, plane, and we're going to fix that by making sure that it does get into a coincidental aspect of this and the line. So now the line is turned black. What I've done is I've selected the center point. This is 0, X and 0, Y, and I've got the line so that it's locked onto this. So I can't grab the line and move it. Right now I can move the line from left to right. It'll slide along this plane, but I can't move it off of the plane. And so it's not completely fully defined, so I want to make sure that it doesn't move. I'm going to use the dimension tool and go from here to the end of this. Come on. Not sure why that didn't want to give me my dimension. There it is. And I want it 1/2 inch from the end. And there's a reason why. And I'm going to refer back to these sketches, this spearhead here that I've already created, so you can see why. I want to make sure, excuse me, I want to make sure that the center of my spearhead the 0x and 0y is right here. This is a reference point for me for when I design the tool pathing so that I always know exactly where I'm at when I go to load in. You can do your design points from wherever you want. This is just my own way of doing this. So we're going to go back to the sketch. I've got my 2.5 inch line. I've got it defined for 1/2 inch from the end, leaving me 2 inches up at this end. And I have it locked in so that I can't move it off of this point. I now need to create another construction line. And this one is, I'm going to do this 2 ways. I need this to be 3/16 of an inch long in the center. And there's a couple of ways. There's always a bunch of different ways to skin a cat, so the saying goes. In this case, I need a 1.87 or 0.1875 3/16 of an inch line that is centered on this. And I'm going to do this one particular way, and then we'll talk about different ways of doing that. So I do know that if it is 0.1875 long, and I divide that by 2, then it creates a line that is 0.94. It's actually 9375, I think. But it creates this line that's half of 1.875. And now I'm going to mirror this line. This is your mirroring tool. So I'm going to select the line that I want to mirror, and I'm going to mirror it on this side. And it should have done that. So we're going to click OK. So we've got the mirror on this side of the line. And this, now we've got a total length. If I did a dimension on here from this edge to this edge, that it would be 0.1875. And this says adding this dimension will over-constrain the sketch. Choose OK if you want to create the driven dimension. You can, but it isn't really necessary. I'm going to delete the dimension. As a matter of fact, for what I'm going to do, I don't even need this other half of the line, because I wanted to show you the mirroring tool, because we only have to create half the profile. So I'm going to delete this line. And I've got my total length, my 2.5 inches long, and my 1/2 inch for the XY, and half of my side of this diamond, this little point right here. And now I want to create my radiuses for my corners. There's a couple ways of doing this. This is the way that I like to do it. I do want this to be exactly 2.5 inches long. I don't want a little over or a little under. I want it exactly 2.5 inches long. And so I'm going to create circles now that match the diameter of the router bit that I'm going to be using, the end mill that I'm going to be using on my CNC machine. The actual dimension of the CNC end mill is 0.197, but I'm going to create a circle that is 0.2 in diameter, and I'm just going to lock onto this line. You can see how it changes when you do that. I'll lock onto the line and draw my circle out and type in 0.02. Okay, 0.0197 is the size of the tool that I'm actually use, but we're looking at 3/10,000ths of an inch difference, and it doesn't really make that much of a difference. So that's the dimension. I'm going to hit enter. I'm good with that. I can pull my dimension out and move it around so it's not in my way. And now I need this to be locked onto the end of this. I want it to be right here. So I'm going to select my coincident tool again, and I'm going to select the end of the line, and notice that it snapped to the circle, and I don't want that. So I'm going to edit it. I'm going to undo the create the coincidence. And this time I'm going to do it a little differently. I'm going to select this and then select this. Notice that since I selected the circle first, it's like, oh, you really do want the outer edge. So this locked that onto that particular spot. These little tools that show up here are references that show you how the object is constrained. So there's a coincidence tool. There's a coincidence, and you can see it right next to the mouse. There's a showing that I'm still in this particular one. I don't need to be in that anymore. I'm just going to hit escape. So I need to do the same thing at this end and the other end. So I'm just going to walk through it. 0.02, enter. Select my coincidence. Lock that in. Notice that it's black now, which means it's constrained and it's locked into that position. And I need another one down at this end. So back to my circle tool. Snap onto the line. Dimension 0.02. Enter. Select the coincidence tool. So now I've got this. Now I'm going to, I want to create tangent lines so that I can trim and have these radiuses as smooth as possible on the corners. This particular diamond is a smooth straight edge diamond. I will create a video for doing a tutorial on how to create curved edge diamonds, which really make it they're a little nicer, they're a little enhanced, but this person wanted a straight diamond, which is perfectly fine. So now I'm just going to create a regular line, not a spline. And I'm going to draw the line a little bit longer than what I need. And just leave it out there in space. I do want to move my dimension tool out of the way. So now I've got this and this line, but I need to create a tangent, and this is your tangent tool. So since this is already fixed, I can select this and then select this line, and it brings it down so that it's matching. It's actually the exact where it rotates on there it's called the line of tangency. If you play a lot of pool, you'll know what I'm talking about. I'm going to hit escape so you can see what I'm talking about. Because if I grab this and rotate it, it stays tangent to that line. But I need to lock it into the tangent point of this one too. So I'm going to escape, select my tangent tool, select this line, and select this. Now I've got my 2 points of tangency, and this line is fixed now also. Now I need to trim this now. I want to trim this edge away, and I want to trim this edge away for right now. I'm going to leave that other edge there for just a minute. Over here, I want to trim away this edge, and this edge, and this bottom half of this, because we only need half of the profile. I'm going to create another line that is going to be longer than this by a little ways. And I'm going to make it tangent to this edge. I'll leave my tangent tool open. I'm going to select this one and select my tangent there. And I select my trim tool now, and this is such a small little teeny curve, but it does make a difference. I mean, you could make this sharp, but as far as doing machining goes, I like accuracy. I'm going to trim off, and this is just this little dimension here is all that there is for that. I'm going to trim off this edge. So this it doesn't show up in anything once we get this done. And over here I'm going to do the trimming of this end and this side and this half. So now I have my half of my profile to make my spearhead look exactly like this one. I'm going to go back to this. And now I'm going to use the mirror tool again. Now, I suggest, and it's just my suggestion, you can do whatever you want, but there's two ways of selecting things. Well, there's three ways, or there's always multiple ways of selecting different things when you're using tools in any CAD program. So whether you're using Bobcat or Mastercam or SolidWorks or Fusion 360 or even VCarve Pro or anything like that, there's usually a couple different ways. One of the rules is that if you draw a line, if you click on a line, click somewhere and draw a box and drag it through the area, it will only include what's inside the box. Notice that it didn't select this line or this line. It only selected that little teeny curve right there. That's all it selected, was that little teeny curve. The other way, I'm going to unselect that, escape, is that if you draw a box from right to left and you drag this down, This is what's called an inclusive box, and it's everything that it's touching. So it grabbed this line and that little curve, but it also grabbed this line, and you don't want that line. So in this case, it's a lot easier if you do the third method and just select all of the lines that you want to use. And you do this by holding the Shift key down. Sorry, we're going to go back to the mirror tool and select mirror. And it says, what are the objects you want to create a mirror of? I want this one. I want this one. I want this little teeny one right here. Make sure you select everything. And I'm just using my mouse wheel to roll in and out of this. And I want this one. And now I want to mirror them on this line right here. So select your mirror line option and then select the line, and it creates the mirror. Click OK. So now I've got a solid image. And in Fusion 360, if you've made a mistake in your drawing and when you mirror something, they're not exact, if you don't get this shadowing when you hover over it, or it doesn't look like it's two-tone like it does now, it's just it's light blue versus this white, then there's an open vector here. You've got somewhere there's a mistake in what you've created, so you want to make sure that you're precise with that. So now I've created that center spearhead. But I need a rectangular box around it because I want to be able to create the inlay and I want to be able to create the pocket. So let's go back to this. And the easiest way to create a box around here that's nice and simple is you can do different ways. You can draw a box like this. You can just grab somewhere and make the box bigger than and hit enter. Okay. The problem with this is that this box is mobile. It can be moved around and shifted in size. And short of, I'm going to just walk through this, you could do it this way. I can dimension this side and call it 2.75, enter. And I can dimension this side, and what is it, 0.57. If I go 0.6, enter. I'm okay, but notice that it's still blue. So there's two things that I'm missing. I'm missing a constraint for where this box is located. If I let go of this, I can just grab this box and move it wherever. And I don't want to do that because when I go to do the pocketing, I want to make sure that I know exactly where this center line is. And the easiest way to do that is to have this box constrained. As you work with programs and learn things, it's your own particular method. It doesn't really matter. So if I wanted to keep this box, I'd have to do two more constraints. I'd need to measure this line that's already selected to the center point and call it 0.3, half of 0.6. Notice that the top and bottom lines are black now. Well, if I get out of this, I can still slide the box from left to right, which means I need one more constraint of doing it from here to here. Sorry, for some reason I didn't select it. Let's do that line and bring it down and call it 0.6. So now I've got my box centered and constrained. Awful lot of work. Okay, this just isn't necessary. There's a lot easier way to do this that saves you a little bit of time if you're trying to draw. Two ways of doing this. I'm going to get rid of all of this. Just deleting the whole box. I'm going to, well, under the create, if you go to rectangle, there's a center rectangle tool, and I can simply click on the very center of this and draw this out, however big, and hit escape, and then put in my two dimensions. I can dimension this And I can dimension this. And now I've got this here. Problem with this way of doing it is that my little inlay is way off of the middle, and I don't like doing that. So I'm going to escape. I don't want to do that. Delete that. And delete that. Here's another way of doing this. I'm going to lock onto the center line. I'm going to draw it up high enough so that it's past where I need it. I'm going to click, draw over, and draw it down. I'll lock onto this line. And now I've created half of a box. And I can mirror that. And my mirror line. If this is too much information for those of you that already know what you're doing in CAD and CAM, I completely understand that it isn't necessary for you to follow along. Just fast forward to the more interesting parts. I'm going to dimension this now. And dimension this. So now I've got a fully defined box again. So ways of skinning cats, whichever way you want to do it, doesn't really matter. So I've got my box, and though it's not exactly, the outside box isn't exactly the same size as this one, it doesn't matter as long as the inside box is. So now that I've got that, I need to create my solids. And when you're machining, the inlay needs to be a couple thousandths of an inch smaller, and there's a couple ways of doing this too. I'm going to show you the way that I like to do it. I'm going to create a solid and select extrude, and this is a new body, and I'm just going to select this outer one, and I want, because my origin, this is the flat plane, the 0 and the Z, I actually want to go down, and the thickness of the material that I'm cutting is 0.065, and so that's the maximum that I want to go with the depth of my extrusion. I don't want my pocket going any deeper than the material. And even though the curve of the radius of the Q itself will allow me to go to the outside edge, this is absolutely the deepest point of the Q, and I don't want it going any deeper than that. Glue notwithstanding or anything like that, I don't need the material going in any deeper. I don't want to take any more off the Q than I have to. So I've got it as a minus 0.065, and you can hit enter or click OK. Notice that I don't see my sketch anymore, because it's thinking, oh, you're all done with your sketch. Well, the sketch is down here, and this is the tool, and I can actually move this back so I don't mess with that. And the sketch, I need to go back and edit it. So right click on it and select Edit Sketch, and now I need to create another solid body, and I'm going to select this one. And when I do, I selected the body, but I didn't create what I wanted. It's going to be called a new body too. You can do cuts or whatever. If you select on this, it'll tell you to join them, but I don't want them to join. I just want a new body. And this one also needs to be 0.065. And I'm going to go the same direction. Backspace 0.65 and hit enter. And notice that it doesn't show the other body. I'm going to grab this and move it back over here. And so now I've got my two bodies. They are exactly the same size. And the only problem with this is that because there's always flex in bits, if I cut out this inlay and cut out this pocket, the inlay is going to be too tight. It's not going to fit in there. You have to try to pound it down in, and you're not going to get a good, even though it might look like it's perfect, it is a little too difficult to do. And you have to decide according to the accuracy of your CNC machine and the bits that you're using and the speed you're running them at, whether or not you actually want to, how much offset you want to give on your space. Remember, there's just a slight little curve right there. It's just really small, but it is there and it shows up. So once you've done this, I need to make a decision. Do I want my inlay to be a little bit smaller, or do I want my pocket to be a little bit larger? Since I'm using a bit that is 0.01975, I can actually know that the bit will fit down in these 0.02 radius corners without any issues. It's not going to try to, when it goes to machine them, it's not going to not fit there. So I'm okay with the pocket being the size that I have it. And so now I want to make my inlay a little bit smaller. And this is how you do this. I'm going to go over to bodies, and I've created two bodies. The first body, body 1, is the one that is this one. Or no, the first body was this one, and I want to hide it. So I'm just going to click off on the eye, and I've got that hidden. And notice I can see my sketch, and I don't really want to see the sketch because I'm afraid that I'm going to select it when I go to select things. So I'm going to click the eye off and hide the sketch. And so now I've got my body. And up here, I can modify this by going offset face. And you can select whatever faces you want, but I want to select all these little edges. And I want to make sure there's that little curve there, that I select that one and that one. And this one. And this one. And then I'm going to turn it around so that I can see these faces. And I need to select that one, and that one last little face. And the arrow tells you which direction it's going. In this case, I'm just going to type in the minus sign, and I'm going to come over and I'm just going to reduce it by 0.02 of an inch. This made my inlay just 0.02 of an inch smaller. And I'm going to click OK. And we're going to check this to see the difference between these two. So let's turn this back around. And turn my other body back on and see the difference. 0.02 of an inch. We can check that by going to inspect, and if I select this radius, it's going to tell me my radius is, or the diameter is 0.2, my radius is 0.01. I can select out of this thing and select this other radius, and it's going to tell me that the radius is 0.008, 0.02 of an inch smaller. This might seem like a huge gap, and like I said, it's according to what your machine does and everything, but it's really not. When we're looking at 2.5 inches, so if you zoom way out of this, I'm still not anywhere down to where 2.5 inches is. It's almost negligible. You can't see it, but it does give you room to get your inlay to fit into your cue or your pocket or whatever you're creating. So I've got those two, and I'm going to close this now, and we're ready to create both either the pocket or the inlay. I'm going to go up to design and select manufacture. This takes you into the machining side of Fusion 360, and I don't need the second body. I want to turn this out because I want to just do the pocket first. And once you're in here and we're on the manufacturing side, a couple things you need to make sure you do. I created this in inches in the sketch side, but when you open up the manufacturer, it wants to default to millimeters. Select this and change it to inches, so that when you are ready to do anything, that it is all in inches and you don't have a big mess up. Especially if your CNC machine is set up in millimeters, that's fine, and you can do it in millimeters, whichever. This is just a training video on how to do pockets. So I do some stuff in millimeters and I do some stuff in inches. So you need to create a new setup. The setup defines where your origin is and the material and how much, if you have extra stock, and where you want to start it, and the direction. Remember I said it didn't matter which plane that you are on. This is my origin right here, and I can simply select model origin and it will be right there. That's where it's going to call 0, 0 when you create this point. You can select somewhere else if you want. Selected point, you can do the ends, you can do the corners, you can do the bottom corners, you can select wherever you want, and this is one of the things I was saying, it doesn't matter. That being said, you can also change where the Z is and which direction the Z is. So if say I want this to be Z, notice that now this is Z along this point. If you made your part on the wrong plane, you can change your work orientation, work coordinate system in this area. I don't need to do that. I want to close this and go back to my model orientation, and I want to select my model origin. Now this is saying that I've got stock material that it defaults to 4/10 of an inch or 4/100 of an inch over on the side and 4/100 of an inch over on the thing. This is if you're roughing materials, it's thinking that maybe you need to flatten the face out before you create the pocket, or you have a jig holding the material or something like that. In this case, it's on the cue, and the cue is mounted in the lathe on the CNC machine, and it doesn't need to be held by a jig or anything like that. And I don't need any extra stock, so I'm going to put in 0 here. And you can either highlight the number or you can highlight the whole thing and hit 0, and it doesn't really matter. It's just going to take that extra stock away. And now you want to give it a name. We're going to call this a 2.5 inch by 0.1875 inch straight spearhead. And this is the pocket, so we're going to go pocket. This is also, we're going to be doing 2 different steps, 2 different operations to create this pocket. So I'm going to go pocket, step 1. And I'm going to be using that 0.0197 in mill. So I want to put this in here, 0.02 in mill. I wasn't able to adjust the width of this so you couldn't see what I wanted to do. We talked about doing a 2D pocket all in one step using a small, really small router bit. And in this case, the router bit would be a 0.02 inch diameter end mill. It's already in for this particular one, I'm going to select it. Even though the bit itself says 0.0197, it's such a small amount in this size that I really don't take any consideration that it's going to make it any difference. So I'm going to select that one, and it's going to disable the flood. I want to change my feed rate to about 8 because it is such a small bit, and my ramp feed to 8, and my plunge to 8. Just overall. The second tab is geometry. I'm going to select the bottom pocket, and under the heights, I don't really care I don't need to change any of this. And under passes, I don't want to leave any stock. If I left that much stock on the side, I wouldn't get way up into this corner. So I don't want to leave any stock on this. And I have to do multiple depths. I cannot cut a full depth cut of 0.065 over a 1/16 of an inch thick with a bit that is 0.02 in diameter. It's just too much. Even with softwoods, I just don't recommend it. You're going to have problems. So you're going to have to do multiple depths on that. So we're going to change this. The rule of thumb for the most part is that whatever the diameter is, you can step down the full dimension, the full diameter. Since it's 0.2, we can actually change this to a 2. And doesn't matter about the finished step down. You can use even step downs, and the amount of step over has to be no more than half. 45% is good, no more than half. So if I stepped over 0.01, I would be okay, but I'm going to go 0.008 for the maximum step over. And I'm just going to click OK. And this is why I suggest learning how to use two tools to do a pocket like this. So I'm going to click OK. And it's going to create all of your pockets. Notice that there's a helix here because it's going to helix down in. We're going to talk about that in a minute too when we change this. But for right now, it doesn't really matter. So if I open up the simulation to create this pocket, and you can create the pocket this way. If you just want to let the machine sit there and run, you're okay. I've got this running at full speed right now. I'm going to hit play, and let's slow that down a little bit more. I'm going to do it again. It's going to do a pocket, and all the way the full distance, one pass. And then it's going to go down and do the second one and the third one. Since it's stepping down 0.02, it's got to do 4 step downs for the 0.065 depth, at least 4, almost 5 step downs in doing the pocket. And when it all gets done, I'm just going to fast forward to the end of this, you can go to statistics and show this takes 24 minutes to cut. That's if you want to sit there and let your machine run for almost a half an hour, there's nothing wrong with that. It'll do that. It'll give you a clean cut. I do recommend a finish cut, but there's a much easier and much faster way to do this. And so I'm going to close this, and I'm actually going to change this pocket. I'm going to edit it, and I'm going to change the tool to a 32nd of an inch end mill. 0.0315. Go to my library, select that one. This is not quite twice the diameter of the tool, but I can do a couple things here. I can change the passes. Notice that it's at 6. Your cutting feed rate can be 8 on this. Different tools, and as I've created them, I've done different things. A ramp can be 8 also, and the plunge can be 8. Because we're plunging into wood, this isn't huge. You don't, unless you're using a spindle motor, you don't have to worry about spindle speed. I don't need this is just an extra M code that's added to the G code when it's all done, and it isn't necessary. So we've selected our tool, we've already selected the geometry, and we're going to go to passes now, and we can step down a full, in this case, you can step down a 0.04. It's a little over the maximum amount of recommended step down, but you are doing wood and you're using a solid carbide bit, so I'm going to go 0.04. And my maximum step over can actually be, if I went half of 0.03 would be 0.015, and I'm fine with that too. So we're going to just stay, it's a little under a half, it's about 48% of the diameter of the bit. And under linking, down in this last one, we've got a Helix Entrance. You can actually change this to plunge, and the ramp clearance height is 0.1. But if you decide that you're going to do the helix, It isn't necessary. You can change these degrees and play with them and try different ones and stuff. And as with everything on here, if you hover it, it'll give you what you're talking about. But the ramp clearance height is 1/10 of an inch. I'm going to leave this and show you what happens with that ramp and some of the time that's wasted on that. So it doesn't matter about entry positions. It can just enter wherever. It's going to probably enter right in the middle. And we're going to click OK. So now we've got this, and haven't changed anything as far as the helix goes. We're going to hit play, and we're going to look at the statistics. And we've cut the time down for cutting this whole pocket out down to 5 minutes. The problem that we have is that right here you can see it doesn't cut this end edge. Okay. So we're going to fix that. Let's do this first. This is the helix coming in. The material's 0.065, a little over 1/16 of an inch. It's coming down and spinning, thinking it's going through some material, and you don't want to break your bit. We spend good money on these bits, but you can cut this distance in half or more. So since it's at a 0.1, right click on your pocket, edit, go to your linking, and down here under ramp clearance height, I'm going to change this to 0.025. This is a little over a 30-second, but watch the difference in what as long as you start with good clearance, you're okay. So we've cut some time there. Did it save us any time? Let's find out. Statistics. It cut it down by almost a minute of time. Well, not quite a minute, about 30 seconds. It took about 35 seconds off of the time. So it's a little bit of time saving, but it is 35 seconds. So saved in your life. And again, it doesn't go, this bit doesn't fit down into the corner of that pocket. You can see where the actual pocket is. So we're missing material here, even though it cuts on this side. So let's go back and figure out what to do so that we can actually cut the whole pocket. And this is a good way of doing pockets. We need to create a different setup. Since I don't have a tool changer on my CNC machine, if you do, you can probably do it all in one offset, but I do need to create another another setup. So I'm going to do setup, new setup. It's going to default to the original, and we're just going to do model origin. The stock material is the same, or from the preceding stock setup. And we're going to call this the 2.5 inch by 0.1875 straight spearhead pocket outline. Step 1. Might seem redundant or too long. You can certainly come up with whatever way you want to name them. But when I do this stuff, I have so many pockets and inlays, I need to be able to recognize it from just looking at the title on this G code. And this one is going to be using the 0.02 end mill. I'm going to click OK. So I've got my second setup here. This one's going to be a 2D contour. And the tool that I'm going to use is my 0.02. That's this one. Select. It did go back to all of its original settings, and I don't need it to be going that fast, so I really want it to cut at about 8 inches per minute, which doesn't seem like a lot until you actually are doing such a small cut as these, and 8 inches is moving pretty darn quick. And disabled, and we're going to select the geometry. And so if I did this as just one, it would just come down somewhere like here, and you can see where it has this lead in and lead out. One cut all the way around. Again, it'll break the bit, especially because we're using such a small bit. So go back into edit, and I don't want that I don't want it to crash into that. I would rather have it ramp. So when we go to passes, I want to do multiple depths of 0.02. So it's going to go down the depth of the radius or the diameter of the bit, make a pass, and then go down to the next depth. And under linking, I'm actually going to do a ramp. I'm going to turn off my lead in and lead out so that it just ramps down through the material. And if I left this at 2 degrees, it would come out, and here's my ramp step down maximum. I'm going to put in a 0 right there. Ramp clearance height again is 0.1. I'm going to click OK so you can see what's going on here. Again, it's going to sit there and do like 6 or 7 passes. 1, 2, 3, 4, 5, 6 before it even cuts into the material. Totally unnecessary. I'm going to edit that. And go back to my linking and change my ramp setup to 0.025. And click OK. Now it's only going to go about 1.5 rotations around this before it actually starts cutting in. And in Fusion 360, you can change the way that this looks simply by going down to your visual style. There's my visual style, grid, visual style, and keep it as wireframe. And now when I select that, and I select simulate, slow this down, play it again. Oh, it's on the first pocket. Sorry. Let's stop that. I'm going to do this one. Close. Let this one, simulate, and let's see what happens. So now we've got your first pass doing this outline, and the second pass, this one, should highlight. Close. Here's your 2 passes overlapping so that you can see what's going on. The first one's going to do the outline, and it'll actually make that whole cut and go all the way down there into the corner the way that it's supposed to in the material that's not. Now, because you have some flex and bits and stuff, since you did the outline and you actually run this pass first, when this pocket, this full pocket gets cut, it'll actually not touch that wall. You can give yourself, say you wanted to leave yourself a little bit of room. I'm going to right click, edit this, and under passes, if you go to stock to leave and you add in a 0 here for radial is the side and axle is the bottom, we don't want to leave anything on the bottom, and we go OK, it's going to leave a little bit of a wall right there. So now we've got our 2 passes. This first one takes a little under 4.5 minutes, a little 4 3/4 minutes to run. So you can pocket it out. And this contour one is going to take just a little bit longer because you are running a lot of ramping. We're going to select that one. I'm going to look at statistics, and it's 6.5 minutes for that. So we've taken the pocket that you can do with 1 bit from 24 minutes down to about 10 minutes total, 10.5, maybe 11 minutes total. You got tool change time in there too, and pulling up the other program, but it certainly works a lot better. So now that I've created this pocket, let's do the inlay. I'm going to save this as a different video. And we're going to do another setup. Actually, I'm just going to go ahead and leave this here. I might edit this out of my setups. I want to go to models and go to bodies and shut this body off and turn this body on. So now I've got my inlay. This one's much easier, much more simple to set up and do. But I do need to do a new work offset, a new setup. So I'm going to go up to setup and select new setup. And I want to again use my origin. On this one, because it's an inlay, it doesn't really matter where you select for this, but I definitely don't want my stock being oversized. So it uses it from the original. But I do want to use my model origin. This will just help me when I'm going, because I'm going to be doing 4 of these and I want to cut them back to back. I want to be able to do one and then move over the distance that I need to and cut the other one and do the distance and cut the other one, turn it around and try to save material. And we'll talk about that later. So I've got this set up and we're going to call this 2.5 inch by 0.1875 inch straight spearhead inlay. And on this one, you can use the 32nd of an inch bit, because I'm going to be using it in puah shell abalone is what it's going to be cutting out. And I want it to be cutting fairly slow, but I don't need to waste a lot of material. And while a 1/16 of an inch doesn't seem like a lot, it ends up being a fair amount. So we're just going to go with the 0.0315 in mil and click OK. This is a contour, and I need to change the tool. To my 0.0315. Select OK. Turn off my thing. I'm going to leave the speed at about 6. I want this cutting fairly smoothly, but my lead in and lead out certainly doesn't need to be that slow. 6, plunge, feed rate 2, good ramp, all that stuff is good. Doesn't matter about any of that. And the geometry is just this bottom edge. The retract height and clearance heights doesn't really matter on this. Don't need to change those. We're going to go to passes now, and it's got this one pass, and same thing. I want to do multiple depths. I don't want it cutting all in one pass. Now you can do different things. One, if I just chose ramp and I left this at 2 degrees and I clicked OK, it would come down and ramp in, and notice that right here it has this exit because I didn't turn off the lead in and lead outs. Let's get this straight so we can see what's going on here. When it comes down and cuts, it's just going to do that one ramp, and it's not going to take very long to cut it, and that's too much on that bit. And also when it exits, it moves off to the side and it's going to crash. I don't care that it's just, a 1/16 of an inch thick abalone shell. It's still harsh enough on this turn and come out that when it hits this wall, it's probably going to break your bit. So, and there's also the lead in here too, and I don't want any of that. So let's edit this. Go back to my linking. I'm going to turn off my lead in and lead out. And I'm going to change the degree from 2 to 0.5, a half of a degree. And my ramp clearance height, I'm going to change that again. I'm going to go 0.05, a little less than a 1/16 of an inch. And right now it's got the maximum step down of 0.02. So it's going to do that on each step. And now we've got, it goes down 0.02 on each one. And this might be a little bit much. Abalone, because it's all pressed and glued together and everything, you don't really want it diving through On that steep, you can see the distance from here to here. It's about half of the thickness of that. This is still too steep, so I'm going to go back in and edit it again. It's one of the things I love about Fusion 360. You can always go back and just, you can see how it looks and then go back and change it. I'm going to change this to maximum ramp step down 0.03. And I'm going to go to passes, and I'm going to do multiple depths of 0.04. I'm going to leave that from the last time we used this. And you can shrink these up just by hitting this. And now I'm going to click OK. And now you can see that we've got about 4 depths of paths going into that. And it still doesn't, I would still rather it take a little bit more time on this. So I'm going to come in on this. It's still cutting fairly aggressively for this size of a bit. So I want to do a little bit more. Let's go back and change it one more time. I'm going to change the ramp to 1/4 of a degree. That should double the amount of loops that it takes. There we go. I'm much happier with this. This doesn't put too much torque on the bit. Notice, let me click out on this. Notice that you've got the 2 blue lines. Since the total depth is 0.065, it steps down 0.04 on the first step, and then it goes around once flat on that, and it steps down the final bit and goes there. I'm going to change that. I want to add in another step down, so we're going to change this step down to 0.2. Backspace. Yeah, if we do 0.2, if we go 0.22, it should be 3 passes. Delete that. And click OK. There we go. So now we've got it where it cuts down in 3 passes. And let's take a look at the machining time for this. I think that it's going to take about 6 minutes. It should take about the same amount of time as the outline for your pocket did. Oops. Sorry. This is the one that I want to do. Geometry. And statistically, a little over 7 minutes to cut out each inlay. So you're looking at about 34 minutes of cutout time, total 35 minutes of cutout time for cutting out all 4 of your inlays. That's not too bad. There's a little bit of changing your location or doing multiple cuts. You can, there's things you could do to make this faster in that sense by making multiple copies of this particular inlay and setting it up so that it cuts one, then cuts another, and cuts another. We'll cover that in another tutorial at some other time, but I wanted to make sure that you understood how these go. So now that we've got that, we've already done the tool pathing for these 2, but we haven't created the G code for those. So I'm going to make this my active, and I'm going to go up to the post processor and click on this. And it's going to give me what it is. Step 1, this is the straight pocket. Step 1, it's the outline. It's got the wrong size end mill in here. Remember, I changed this. This is the pocket, so it's actually... sorry, I'm going to cancel this and just double check. Edit this. And it is, I've got it as step 1 here, but it's actually step 2. change that to step 2 and click OK. I want to make sure that that's the whole pocket. Then I'm going to double check on this one, make sure this is active. Right click, edit this. Check on my names. This has got the right one. Straight pocket spearhead step 1. Okay, for some reason I had called the other one wrong. Good way to just double check on those. So I'm going to go up to my post processor again. It's going to open up. I've got this as a straight spearhead pocket step 2, 0.0315 in mill. Right here under save free tracks, pay attention to this. If you select G28, there's nothing wrong with doing that in this particular setup. What it'll do is it'll get done with its cut, it'll raise the bit up, and the G28 says to move to X0, Y0, Z0. You can change the G28 in Mach 3 so that when it reads the G code, it will be wherever you want. But just know that as default, it's X0, Y0, Z0, and that might cause you problems. You might not want it to touch on this material at the Z plane. So I usually just go clearance height. This is when it gets done with the pocket, and when you have the passes showing wherever it raises up and stops, that's where it stops. Nothing wrong with that. I like using that, but you can do it whichever way you want. I'm going to post it. Save it. And then right here you can click view the NC code. And it comes up, and as I've gone through before, it's what it's called, the size bit, the dimensions, where Z0 is minus, this is the final depth, and it's a flat end mill. And your G codes, you'll have to go through and read those and get used to what they do and say. And this is your whole coding. It's a lot of coding. So I know that sometimes, I've already saved it, I'm just going to close this. I know that a lot of times people say that traditional milling is more complex or harder, but in reality, while the simplicity of creating a G code is saved a lot of steps in using something like Fusion 360 or VCarve Pro, there's also a lot of complexity that you need to make sure that you know and understand. I would challenge anybody to say that making a queue traditionally, not using anything like a CNC machine, builds you a better queue. I don't believe that. I think that you can actually be more accurate and have more intricate designs and patterns and inlays and have a complex design that gives you much more of an aesthetic look and uniqueness, especially when you're doing one-of-a-kind custom queues. Most of the queues that I design for people are one-of-a-kind, and they're not designed. I don't make the same queue for anybody else, and so that's what people are paying for. And being able to learn this gives you that ability to be able to completely design something that's very unique to that one particular queue. If you want to use the spearhead for multiple queues, there's nothing wrong with that. I have done queues that I've used similar inlays or patterns for because the person was like, no, I like that. I like that little diamond. That'll work really good in it, while the rest of the queue has some uniqueness. So I just don't do a whole queue that looks exactly the same. So we've posted the process on that one. We're going to go to the second one here. This is the outline, and I'm going to post the process on this one. This is step 1 because it is the outline. It says outline, clearance height, post, save. I don't need to look at the V. And now I'm going to do my inlay. One thing I didn't talk about is that same thing when we're doing the spearhead inlay, the type of bit we're doing, and the clearance height in post. You might have noticed that right here where these 3 NC programs are, there's a little warning. The warning on this particular case is since we didn't use stock that had extra stock, If you click on the warning, it'll tell you work offset has not been specified using G54 or work coordinate system. There's not a work offset because I don't have any extra stock that I have to be aware of that I'm using on this. But these are always good. Read them. They're pretty easy to find, and if there's anything wrong with the problem or the program or anything like that, you'll be able to see it right here, and it'll tell you what it is. So there's that. And now we will go cut out those pockets on the cue, and hopefully they work out right. And then the inlays. Thanks for watching. Stay tuned. I do want to make sure that I am. Okay, so what I'm doing here is finding the Z0 plane on top of my piece of wood for where the inlays are going to go. So I use a piece of paper. This works really good. I'm slowly lowering the bit down just at like, I don't know what it is, 5% or something like that. And I'm moving I know it looks like my hands are shaky, but I'm actually moving the paper around just until I get a little bit of tension. And when it stops moving, and like there, it's just snagged right there. I do know that I'm in contact with the wood and the piece of paper, and the paper is about 2/10,000 of an inch thick, 20,000 of an inch thick, or something like that. 2 steps. So what I'll do is I'll back off, and then I will lower it 3 steps and call that 0, so that I know that I'm exactly at 0 at this point. I also know that I am at X0, Y0, and Z0. This is the center of my inlay. And I get questions sometimes about whether or not you should use a probe to find the 0 plane. It works really good if you're doing metal, but wood is non-ferrous, so it doesn't really work for that. And there's also a little bit of difference because of the rotation of the head. I'm at Z0. X0, Y0, this is the center of my pocket, this long little 2.5 inch diamond inlay that I'm going to be doing. And Okay, so what I'm doing here is finding the Z0 plane on top of my piece of wood for the where the inlays are going to go. So I use a piece of paper. This works really good. I'm slowly lowering the bit down just at like, I don't know what it is, 5% or something like that. And I'm moving I know it looks like my hands are shaky, but I'm actually moving the paper around just until I get a little bit of tension. And when it stops moving, and like there, it's just snagged right there, I do know that I'm in contact with the wood and the piece of paper. And the paper is about 2/10,000ths of an inch thick, 20,000ths of an inch thick or something like that. 2 steps. So what I'll do is I'll back off and then I will lower it 3 steps and call that 0 so that I know that I'm exactly at 0 at this point. I also know that I am at X0, Y0, and Z0. This is the center of my inlay. And I get questions sometimes about whether or not you should use a probe to find the zero plane. It works really good if you're doing metal, but wood is non-ferrous, so it doesn't really work for that. And there's also a little bit of difference because of the rotation of the head. So we're working with such small parts, the paper method works really good in my opinion. Okay, I've started the program and it's running down through its helix cut into it. If you were cutting really hard material and you had extra stock, that's why it would be doing that. It is a little higher clearance than necessary, as I had talked about in the Fusion 360 portion of this tutorial. The pocket does a pretty nice job here. I'm going to let you watch it, put a little background music maybe. Enjoy. Okay, we've just created that pocket. Now I need to rotate 90 degrees and do another pocket. And I want to make sure that I'm centered on the center of my point. So let's walk through this. First thing I need to do is go to MDI. And since my angle is at 0 right now, I have already typed in the G0A90. And you can just scroll back up through that or retype it, whichever way you want to go. So I got G0A90, and when I hit enter, it'll rotate 90 degrees. Okay? But I do need to make sure that I'm in the center of my point. So I'm going to use the tab key to open up my scroll. And if you've got a Game Boy handle or something like that, or a joystick, that's fine. This might be too much information for some of you that are already CNC and Mach 3 savvy. But for those of you that are still trying to learn, I just want to walk through this. So I've got my speed set up to 0, and I've got it in jog mode, and I've got it set up at 100%. So I do want to watch this carefully. I'm going to put it over the X and bring this down, and I'm just going to bring my head all the way up to the center of this point. A little bit further. You can see what I'm doing here. Make sure my focus is on this. And I'm going to slow it down to 5% now. And lower the bit until it's almost touching. And I want to make sure that my Y is on 0, because notice that it's not. I'm not on center here. And I did make the mistake of not going to G0, Y0. So I'm going to just type in G0. I don't need to go to X0 right now. And hit enter. And it moves that over. So now I can see if I'm close to being on center. It looks pretty good, but again, I want to lower my head down a little ways and see if I'm right in the center of that point. This looks pretty darn good. To some focus right there. So I'm going to move over this. Move forward a little ways just to check this. See if I can hold this steady enough with my hand. Right up to the tip of that. Looking pretty good. I'm going to lower just a little bit more until I'm almost touching the wood. It might be a step or two off. Just a little bit to the left. So I'm going to set my speed to 0.1 and jog mode and step over. Going the wrong way. I finished centering that and called it good and set that as my 0. It ended up being off at about 0.3 of a degree, which wasn't too bad, and just called that 0. Quick little video on putting down, doing inlays we're going to cut out 4 little point inlays for that Q. And to hold this material down, there's a couple ways of doing it. You can do masking tape on both sides and then you super glue on it. You can buy this stuff, which is a double back CNC tape available on Amazon. Pretty cheap for the price. And I just need a piece that's about as long as my material. And I've already cleaned the bed of this off. And I just use scrap cabinet shelving material you can pick up at any Connects or Menards, Ace Hardware. Well, I can't buy shop or Home Depot or Lowe's or any of those guys. You can buy it pretty cheap. It used to have a better coating on it. Now most of the time it's melamine, so you have to get pretty good stuff. I was lucky enough to, if you can find it at yard sales, I just cut these up and use them. So I've put the tape down and rubbed it down really good. Just going to peel the back of this off. And I decide which side I want to be up and just stick it down on there. Pretty easy to do. Now I don't want I'm going to put this piece down on here, just cover this back up. This is the 0 plane, or this is the 0.065 for the thickness of the material. So I'm going to bring So I've got my CNC head here, and I've got the bit that I'm going to be using. I do want to know where the material is going to be stopping. I don't really want to cut into the adhesive material in the back, so I'm going to get down to where I'm almost touching. I'm going to bring it over here, and we're going to do that trick with the paper. And do it on this side. Slow this down to about 10%. It's just almost touching, and use a piece of paper with my other hand and see what's going on. Slide a piece of paper under there, slow this down a little bit more, bring it down so it just doesn't move. I'll step up a couple steps. This gives me just enough clearance, and if I call this on my Y or my Z, if I call this minus 0.065, the top of the material will be the 0 plane. Hope you can follow along with what I'm going to talk about here. I'm trying to save as much material as I can. This abalone is pretty expensive. I'm going to slow my feed rate down to 10. I've already got my Z space set. And I know that this is the very edge of, almost the edge of the abalone shell. And if I call that minus 0.5 on the X, that my inlay, and I know that the center of my inlay is where I need it. I'm going to edit this out. I also need to know where this edge is. I do know that my material, my inlay itself, is 3/16 of an inch thick. Go down a little speed. So that I'm almost on that edge. Since 0.1875, half of 0.1875 is basically 0.1, I can call this on my Y, I can call it 0.1. And now if I go to my MDI and type in G0, X0, Y0, and hit enter, But this is going to give me this small inlay pocket right here. I shouldn't have. And now we're ready to do the cut. I've started up the program. It's going to move rapidly over to where its entry is. And we set this up as a ramp. So it's going to ramp its way down into the material bit by bit. And it takes a little while for it to cut. It's only cutting about 6 inches a minute. I think that we said this cut was a total of 7 minutes. And so that's about how long this video is. You can fast forward through it if you like. Okay, after it got done cutting, I very carefully pried it up so that it wouldn't get any damage. The bottom edges of this are a little rough. You can see some of it there. So I'm just going to take a piece of sandpaper and kind of clean it off a little bit, and then we'll see how it fits. So here's my pocket. Here's the inlay. Just going to set it there and lay it down in. And all gets clean and done. It's going to be beautiful. The 2,000th of an inch glue gap is minuscule. There's no wobble. I'm trying to get that to focus. There's no wobble in there. Get that to zoom in on that. There we go. Cut out 3 more of those and we'll be good to go. Okay, I finished cutting out all 4 of the inlays, and I didn't waste the time having you guys watch all of that. It took forever, about an hour. And then carefully prying them up so that they did not get damaged. They all are in good shape, and we're going to see how they fit now. So honestly, I already checked the fit on these. I'm just going to put them in. I'll lay them in nice and snug. Make sure I have the bottom edge where they were cut here. Is the bit just didn't quite, I didn't want it hitting the adhesive, and so I left it a couple thousandths up, and that worked out really good, but it does leave a rough edge on the bottom of them. So having that as the top of it fits in good. Slide this third one in. Just going to get them all 4 set in here. So that you can see how that turned out. Once I have them glued up, I will sand them down and we'll see how it looks.